Okay, hey everybody, Mr. Bells here. Just wanted to let you know that I'm going to try and give you the best that I can on this little review sheet. So first off, it says use your graphing calculator, so we need one of those things, to find the minimum or the maximum value of 2x squared minus 2x minus 6. So I'm going to go here, turn it on, clear my home screen, go to my y equals. That's for something different for you guys. Most of you are in that y equals. I'm going to clear out both of those equations and put it in 2x squared minus 2x and then minus 6. When I have that in there, I can go ahead and hit zoom 6. Zoom 6 just means that it's going to graph it, like you could hit the graph button right here also. But it takes it to a negative 10 to 10, negative 10 to 10 window. Well, this first question says find the minimum or the maximum value. Well, I think it's obvious that this parabola right here has a minimum value. So we're going to find a minimum. And I hit second trace. Number 3 is minimum. And then it asks me to pick something on the left side of it. And I can either move my cursor and hit enter to pick that number, or I can just type in a value to the left side of it. So I'm going to go ahead and type this time. So I'm going to hit negative 5. And hit enter, and you can see that it puts a boundary line at negative 5, and then it says right bound. So I'm going to pick 5 and enter, and it picks something on the right side of it. So what it's going to do is going to find the lowest value of this parabola between those two lines. So it says, do you want to guess? I really don't want to guess. I just want to know the answer right now. And I hit enter, and you can see that it's 0.5000000003 and negative 6.5. Well, that really means that it had some rounding errors. It's really just 0.5 and negative 6.5. So I would go here and I would put 0.5 comma negative 6.5, and that would be a minimum value. Okay, so as we go through the rest of these ones, this next one says minimum or maximum. You can go ahead and try that one on your own. Because the equation's negative, that means the parabola is going to open like this, and it's going to be a maximum. I'm going to go ahead and do it, but I'm going to do it a little faster just so you have the answers here. So y equals clear negative 2x squared plus 4x minus 3. And when I'm typing these things into the calculator, I'm probably going to really take some time on this and make sure that I know that that is the actual equation, because if I type in the wrong stuff, it's gonna mess me up. So go ahead and hit graph. I obviously see that that is a high point right there. Second trace, number 4, this time maximum. Enter, this time I'm just going to move my cursor. Enter, there's my two boundary lines. Enter, and it's at 1, negative 1. So in terms of my solutions, 1 comma negative 1. And that's a maximum. This says complete the square for the expression x squared minus 16x plus what? And then write the resulting expression as a binomial squared. Well, we said every time we take half the linear term. So half of negative 16 is negative 8. We put that in the little square box. And anything that's in the square box we square. So negative 8 times negative 8 is positive 64. That's what a completed perfect square is. And it results in x minus 8 quantity squared. X, and whatever's in your box every time. These ones simplify the radicals. Square root of 50 breaks down into 2 and 25. 25 is 5 and 5. Those are all prime numbers. I circle my two twins, and I get 5 square roots of 2. On this next one right here, I cannot for this thing, leave a radical in the bottom. That's one of our rules. So I multiply top and bottom by square root of 10. That'll give me 3 square roots of 750 over 10. 750 is, I'm going to break that down here. 750, that becomes 10 and 75. 75 is 3 and 25. 10 is 2 and 5. 25 is 5 and 5. So it looks like I got a 2, a 5, a 3, a 5, and a 5. Well, I can take those twins right there and pull them out. That gives me 5 on the outside. Square roots, I got a 5 and a 2, which is 10 times 3 is 30. And then I still had this 10 on the outside, or on the denominator spot. And I had this 3 that I'd already pulled out there. So from the 3 and the 5 that came out from the twins, the 3 that was already there, and the 10 that was there, I end up with, for final answer, that 5 can kill that 10, 3 square roots of 30 over 2, because 10 is 2 times 5. So that 5 killed that 5, and I left a 2 downstairs. Just reducing fractions. Okay, this one right here, I've got 5 cube roots of 24 and 3 cube roots of 81. Of course, I can't add these two fractions, or add these two rationals together, unless, of course, they are the same radical. So I'm going to try some stuff here. 24 is 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. And look at that. I have triplets. So when I pull that out of there, pull a 2 out, so 2 times 5 is 10. So this first one becomes 10 cube roots of 3. This next one, break down 81, that's 9 and a 9. And then 3 and 3 and 3 and 3. So I have triplet 3s. This 3 times the 3 that's already there is also 9 cube roots of, and this is the 3 that's left over, just like that was the 3 that was left over. 9 cube roots of 3. So I have 10 cube roots of 3 plus 9 cube roots of 3, or 19 cube roots of 3. This next one, this is kind of big, and maybe you're thinking, ooh, I don't know if I can do this without a calculator. And my numbers will probably be smaller if that's the case on it. But what I'm going to do is this. I'm going to go 1250 is 2 and 625. 24 is 2 and 12. 12 is 2 and 6, and 6 is 2 and 3. So what I can do, since they're both fourth roots, is kind of like do a fourth root over all of those things. And I'm looking for quadruplets. Well, this is a special quadruplet. That 625 is 5 times 5 times 5 times 5, and that's from your chart. So if you needed that, you could look at it that way. So I can pull a 5 out from this, and then I've got, do you see that? Quadruplet 2, so I can pull a 2 out from that. So when I pull a 5 out and a 2 out, that means I'm really pulling 10. And I look, and I got this, so 1 left. So 10 fourth roots of 3, and that would be the final answer for that one. Okay, I'm going to get a little closer on these ones, blow that up for you, maybe this is helpful. So this one, simplify the expression, the cube root of 125 y to the 12th. Well, if I have my chart, or if I just know my multiplication tables really well, the cube root of 125 is 5. And then how many triplets do you have out of 12? You have 4 sets of triplets, and that's actually it. That's the final answer, because there's nothing left inside. Again, if you wanted to do it longer, you could write 125 as 5 times 5 times 5, and y to the 12th is y times y times y times y, and you can see that there's 4 sets of triplets, and that's why those are all on the outside. And everything comes out because they're all in triplet sets, and that's why there's nothing left in. You don't need the radical. Okay, here we go. Cube root of 216, x to the 5th, y to the 7th. So cube root of 216 is 6. Out of 5 x's in here, x, and I want triplets, that means I got 1 full set of triplets, and I have 2 of them left over. And y to the 7th, I have 2 full sets of triplets, and 1 of them left over. So that's what that answer would look like. That goes in that blank right there. This one over here, and again, you can stop the video at any time. Try this problem beforehand, and then go through and watch what I'm doing. I'm hoping that you guys are not just copying down answers, but you're really trying to make sure that you understand why you're doing what it does. The points that you learn on the test far exceed what we'll get out of this worksheet. So here we go. Fourth root of 80. I don't know if there's anything in here, but that's an 8 and a 10. 8 is a 2 and a 4, and 4 is a 2 and a 2, and 10 is a 2 and a 5, and you're like, oh, look, 1, 2, 3, 4 2s, and I need quadruplets, so I know I got a regular 2 here. I'm going to go ahead and put the radical way over here, and I can see that there's a 5 left in there. Now for x's, I'm looking for quadruplets, so it looks like I get one set of quadruplets out with 1 left in. Y to the 7th, I get one set of quadruplets out with 3 left in. And z to the 12th, looks like I got 3 sets of quadruplets. And there is no z's left in. They all work together to be able to come out. So that's what page number 1 looks like. I'm hoping that this was helpful. Looks like I'm probably going to have to make 2 videos for this thing, because I don't know that we'll have enough space or time to be able to do it. But I'm going to go through this here. Here we go. So again, this bottom number, when we have a fractional or rational exponent, this bottom number right here is considered the root, and it's the same thing as saying the cube root of 64. The top number is considered the power, and that's the same thing as saying 64 to the 2nd power. And then the negative exponent, we push that down through the fraction bar and it becomes positive, or we push it up through the fraction bar and it becomes positive, depending on where it already is. Okay, so I'm going to kind of do this in my head. The first thing I'm going to do is the cube root of 64, and that's 4. So when I deal with this, I'm really going to have 4 to the negative 2 power. And then when I deal with the power, ignoring the negative, I'm going to have 16 to the negative 1 power, because 4 squared is 16. And then anything to a negative exponent like that is that same number in the denominator with a positive exponent, 1 to the 16 to the 1st. But we don't ever write the 16 to the 1st, so it's really just 1 over 16. Okay? That's my final answer for that. That's all non-calc. Those are all things you should be able to do. Make sure you have your chart. Okay, so on this one, you're going to look at the root, right? So what is the square root of 16? Well, that's 4. So that's rewriting it. It would be 4 cubed, because the square root of 16, right? Because that's in the denominator. That's in the denominator spot. 4 cubed is 64, and that's your final answer there. So over on this one, I'm going to go ahead and deal with the negative exponent first. So that means that I could rewrite this as 4/5 to the positive 3 power, because a negative exponent on the 5 moves it down and makes it positive. Negative exponent on the 4 moves it up and makes it positive. So it basically just means that I have to flip the fraction. And now I can just go ahead and cube both of these numbers. So 4 times 4 times 4 is 64. And 5 times 5 times 5 is 125. And I know that I can't reduce that at all, because the factors of 125 are just 5s. And 5 doesn't go evenly into 64. Okay, here we go, number 8. Number 8 is solving a radical equation. So key thing here is I need to isolate my radical. So I'm going to go ahead and move this 1 over first, and I get the square root of x plus 2 equals 8. Now I have the radical isolated, and I got to do that every time on these problems. No, so now I can square both sides, and I get x plus 2 equals 64. And I get x equals 62, because I subtracted 2 from both sides. You guys know that if this is on the calculator version, store 62 into here, and you can kind of check it in your head, right? 62 plus 2 is 64, square root of 64 is 8, 8 minus 1 is 7. Check, that one worked. Here we go, solving this equation. This one takes a little bit more work. I'd probably have you use your graphing calculator for it. So again, same thing, I have to isolate the x. So I'm going to get rid of the 56 first. So I'm going to add 56, one side of the equation, other side of the equation. And I'm going to kind of push this all into the calculator at one time right now, and hopefully you guys can follow me on that. So I'm going to start with my answer, 240,892, 240,892. Make sure I typed it in there correctly. I have to add 56, so I'm going to do plus 56. I'm going to hit enter. And then I have to get rid of this 24, so I'm going to divide by 24 and hit enter. I got this number. And now I need to get rid of a 3/7 power. So I'm going to simply raise that answer, and I can just hit this key right here. Raise it to the reciprocal of 3/7. So parentheses 7 divided by 3, close parentheses, so it's raised to the 7/3, because that's how we undo a rational exponent. And then I get this. So yes, my answer is, what is that, 2,174,343,709. And that's it. That's the solution to that. Okay. So I'm going to do the next one right now. And this one is, I'll blow this up a little bit more here so you can see it. And again, if you're at home watching this on your phone, you should not be watching this on your phone. Pull it up on your Chromebook, pull it up on your computer, pull it up on something. For all you gamers, pull it up on your big 42-inch, whatever, 64-inch TV so you can really see this stuff. Okay, so on this one, I already have a radical, so it's a radical equation, similar to number 8. But on this one, the left side is already isolated. I don't need to move anything over to the right side. So I'm going to square both sides. And when I square the left side, I get x minus 1. When I square the right side, I actually have to FOIL that, because x minus 3 squared means x minus 3 times x minus 3. So I get x squared minus 6x plus 9. It's a quadratic equation. Remember, we set quadratic equations equal to 0. So I'm going to subtract x and add 1, subtract x and add 1. And now I get 0 equals x squared minus 7x plus 10. That factors. Got to know our factors. So again, things that multiply together to get 10 and add together to get negative 7. That's x minus 2 and x minus 5. Which means my solutions are x is equal to 2 and 5. And what I'd want to do is I'd want to check those back into my original problems. So when I check 5 up here, 5 minus 1 is 4, square root of 4 is 2. 5 minus 3 is 2. 5 checks. Yay, works. Real. Check 2. 2 minus 1 is 1, square root of 1 is 1. 2 minus 3 is, negative 1. So that means that this solution, 2, is extraneous. And we have to be able to differentiate between the two of those. An extraneous solution, again, is a solution that works for what we solved, but doesn't work in the original problem. Because sometimes we have to do some processes to help solve this, where we get extra answers that don't necessarily work. Okay, here we go. So this one says solve this, 3x plus 18 to the 1/2 power equals x. I want to make sure that you guys are all clear on this, that the 1/2 power is the same thing as a square root. So I'm really just solving this. Sorry, it wouldn't have the squares on them, but that's what I'm going to do next. And I wrote it in ink, so hey, we're going to live with it. So I square both sides and I get 3x plus 18 equals x squared. There's another quadratic, set it equal to 0. X squared minus 3x minus 18 equals 0. Parentheses, 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 parentheses. Factors of 18 that differ by 3. That's 3 and 6, so x minus 6 and x plus 3. Remember again, they have to multiply together to get negative 18 and add together to get negative 3, and those simply do. So that means my solutions are 6 and negative 3. Now, of course, I'd go ahead and take those things and I'd plug them back in. 3 times 6 is 18 plus 18 is 36. Square root of 36 is 6. Check. Negative 3. 3 times negative 3 is negative negative 9. Negative 9 plus 18 is 9. Square root of 9 is 3. Ooh, real and extraneous. So hopefully that's helping. Here we go. Multiply these polynomials. That's when we FOIL. So 3x times 4x is 12x squared. Inside is negative 20x. Outside is positive 9x. And last two terms, negative 5 times positive 3 is negative 15. Make sure on each one of these products that you take and keep the signs with them as you go. Final answer, 12x squared. Those two terms go together to be a negative 11x minus 15. Final answer. This one requires a little bit more work on it. So 5x times x squared, I'm going to do the 5x to this one, the 5x to this one, the 5x to this one. I'm going to try and line these suckers up. So that's 5x cubed. 5x times negative 4x is negative 20x squared, and 5x times 2 is plus 10x. I'm going to do the negative 3 now to each of these three terms. So negative 3 times x squared is negative 3x squared. And I'm going to line those up with the quadratics, or the linears, or the constants, whichever one we have. Negative 3x times negative 4x is positive 12x, and negative 3 times positive 2 is negative 6. Add those things together, and I get 5x cubed minus 23x squared plus 22x minus 6. Final answer. Okay, so finishing the last two up on these pages. So this is a rational expression. When it says assume that all expressions are defined, that means I don't have to put down the whole z can't equal 0, y can't equal 0 because they're in the denominator spot. It's just saying, hey, we're going to let everything be okay for right now. So there's no plus or minus signs on these ones. So when I have that, that means that I can really just kind of extend that fraction bar because it's all multiplication. So now I'm just going to reduce stuff. So I'm going to go ahead and put its answer right here and save this problem, put its work down here. So you can see that I'm going to look at the numbers first. So this 8 is really a product of 2 and 4. So then that 4 kills that 4. This 9 is a product of 3 and 3, and that 3 kills that 3. So if I'm looking just at coefficients, it looks like I have a 6 left upstairs. This 2 times that 3. Now x's, I have 4 x's upstairs plus another one upstairs, so that's 5 x's upstairs. I don't have any x's downstairs, so that's x to the 5th. I have y squared upstairs, a y squared upstairs, so y to the 4th upstairs, and a y to the 4th downstairs. Those should kill each other, so all the y's go away. And now I have z to the 6th upstairs and z to the cube downstairs. They fight it out, and it looks like I have z cubed still upstairs. Now, since this is all written over 1, because there's nothing left downstairs, I can just write it without it being a fraction. But if there was something still downstairs, I have to make it still in the denominator spot. Okay? On this last one down here, this is a division symbol. So we said when we divide fractions, we copy the first fraction, right? Copy. We change it to a dot or multiplication, and we flop the second fraction. So I have this. Now this becomes the same problem as number 13. Remember again, like I said earlier, feel free. You can stop this video at any time. Practice these ones on your own. Please don't just copy answers. I literally have had people that had identical looking pages to mine with everything in the exact same place. Make sure that you know how to do it. Okay, here we go. So I'm going to fight stuff out. So this 5 kills that 25, leaves me with 5 down here. That 3 kills that 3. So it looks like I've got a 5 left in the denominator. It has to go downstairs because this is division by 5. Now x's, I have an x cubed upstairs and x squared downstairs. That leaves an x upstairs. I have a y to the 9th upstairs and a y downstairs. That leaves a y to the 8th upstairs. That's all of my stuff, and that is my final answer. Okay. Again, take your time. Make sure that you understand all of this stuff. Mr. Ells. I will talk to you later, especially because this is probably Monday when you're watching this. If this is 2021, when the sub's going to be here, take care of it. Check all your stuff. Make sure you understand it. I'm hoping this video helped. We'll see you later.